and let's get started. It is my pleasure to introduce Elizabeth Iwasawa from Leidos. Elizabeth is the quantum technology lead at Leidos, a science and engineering research company. And in the quantum space, applications are broadly explored. Quantum machine learning, simulations of materials, even astrophysics problems like quantum teleportation, black holes, wormholes. In your PhD, Elizabeth, she actually looked into an entirely different topic, probing cosmic ray anisotropy in the northern hemisphere with atmospheric neutrinos. And this might be very welcoming to some participants who are in that field and now also looking into quantum applications, quantum computing and sensing, adding that to their expertise or transitioning. So looking forward also to hearing your personal story and how you got into quantum and what you do there. Please take it away, Elizabeth, quantum technologies in industry and at Leidos.
Thanks, Marlou, and thank you so much for inviting me to speak with you all. So I'm going to give a sort of scattered talk where I took a sort of non-standard route through technology, as you just gathered, since Marlou discovered my PhD topic. So I thought I would get into some of how I got into the role that I'm in and either reassure or demonstrate that there are lots of different ways you can get here and many things you can do after you make certain choices in your career, then talk about the particular kind of corporation I work for and what that looks like on a daily basis, different ways to be involved, so very broad. And then some of the use cases that we look at, I'd like to highlight some other companies in the industry as well, just not out of any particular bias, but to give you a really broad idea of what's possible. So let's dive right in. So it gets even weirder than the PhD. I actually started my undergraduate career in creative writing. And so you can basically start with anything and end up in quantum technology, which is my message to anyone. So I started with that, and I took quantum mechanics on a dare because one of my friends said she thought I would like it. And I fell in love with the subject. So I went back to school as a post-bac and I bartended to keep myself afloat. I did a master's in material science. There was a change up in my university, so I ended up finishing my PhD in particle astrophysics, looking at astrophysical neutrinos. That led to a postdoc in dark matter, which I've just noticed I've misspelled on the slide. And then I took one of my first industry positions in a sensing group that led me to do work in maritime autonomy. So even with just standard sensing or quantum technology, there are many ways to do all kinds of different work. And sensor scientists and computer scientists are very valuable in other fields you might not expect, such as autonomous platforms. I looked at undersea vehicles, and that's been actually very helpful in a lot of the work that I do as a quantum technology lead by understanding where people want to use some of the things that we develop. After that, I was brought over to Leidos to help develop their quantum strategy at a corporate level, sort of explore what made strategic sense for the company, where they should invest, what they're interested in, what makes sense with their customers and their product lines, and also help them develop an R&D portfolio that they can work with. So if that doesn't reassure you that you can make a couple weird decisions in your career and still end up where you may as well have wanted, I don't know what else will. So I hope you take this as a grain of salt that there's always an option available in many different ways. So what is a quantum technology lead? It's a pretty vague title. It sort of reflects that a lot of companies that might not be quantum focused or even heavily research focused, they're noticing that quantum is a key field that's rising in the government's interest and industry's interest. And there's a huge focus on cybersecurity right now, as reflects in quantum computing, which I'm sure someone has discussed already. But there's a lot of interest in companies to start bringing in these SMEs, so subject matter expert, to explain to them what is quantum, how does it work, can we use it, or to help them figure out what's hype, what's not. So companies are very aware that there is a lot of hype about quantum technologies and what they can do, so they're relying on our expertise to help guide them as well, which is really fun. So what kind of things can you end up doing in these roles? A lot of it'll look like being a professor where you're building labs and starting research groups from scratch. Some of it becomes very sort of business development and partnership where you're looking to work with other companies, you're looking at startups, you're looking at academia, you're looking at other big companies. I'll get a little bit more into the type of corporation that I work for, but you're never really locked in an industry to just your company and just your group. There are many chances to collaborate across academia, startups, everyone that you can work with, the national labs, as Marlo was mentioning earlier. Figuring out that broad fit with company expertise. So if Leidos has a bunch of people, as you were just hearing, quantum AI/ML is a key thing. If we have a lot of people who are familiar with AI/ML and how cloud processing works, can they do quantum computing with minimal training? If we have a lot of people in civil looking at developing new energy infrastructures, they can also leverage quantum computing. We do upskilling and develop upskilling programs, which is corporate language for teaching and going back to school, basically. So how do you train an adult who already has a career to integrate and fit quantum technologies into it? And then trying to understand what the government or industry wants, or even just people like us. What do we want? Do we want a quantum toaster? Maybe not. But do we want, quantum AI-enabled cars? Probably. Then, doing things that sound very familiar to people who are still in academia. We lead programs. We write proposals to get grants or funding from external companies. We run programs. We run research efforts. So I'm a PI on technical programs as well as a salesperson and a strategy developer. We also have technical fellows in corporations like this, where they are basically corporate academics. Their job is to publish, do research, write. We have things called solution architects. So these are people who are supposed to be relying on a broad expertise and background to combine quantum technologies with maritime platforms and propose new solutions. So even if you have a diverse background, that's actually usually a benefit in these kinds of fields. And just for fun, there's a lot of ways to do quantum in industry as well, besides sort of a research scientist, which is really close to the technical focus, towards something called BD, which is business development, where you're basically a salesperson for quantum research for your company. In between there, there's the principal investigator who leads research. There's program managers who actually start looking at the business and management side of quantum. How do I run a lab? How do I run a program? Minding finances, deciding what kind of equipment to buy. There's directors who drive strategy. So there's many different ways you can do quantum in industry, and I just wanted to kind of put those out there. So I work for a company called Leidos, which we'll get into, which is a system integrator, which is I didn't know that those companies existed before I joined, so I thought I would explain sort of what those are and what they do. They kind of fit in a very specific slice of the industry. If you've heard from MITRE, you might have some similar ideas. But you kind of have quantum technology companies on one side where they're very specialized. They tend to be small startups. They're spun out of academia. Not always, but sometimes they have, small specific product lines or research that they're focused on. I put an example here, like PsiQuantum. Um, on the other side, you have like big industry that we're familiar with. These are people like IBM and Microsoft. And I'm just picking names out of a hat. There's no corporate sponsorship or favoritism here. Just sort of picking examples. And they tend to have these large, product lines where they'll have teams of quantum scientists, or they're building their own quantum computer. They have foundries and facilities and laboratories, and they make something, it's high TRL, which is our way of saying a tech readiness level. So you could basically buy it off the shelf. It's not an R&D prototype. And in the middle, there's a type of company that does a lot of interdisciplinary collaboration. They help small companies maybe figure out how to take their sensor and put it on an airplane that the Air Force wants to fly, or they can help do the software support for a quantum company that doesn't want to pay a lot of software developers. So they tend to have a really good idea of the sort of civil and government customer base. We tend to have a lot of cleared personnel to work on sort of social national security issues. We have a lot of diverse use cases. You don't tend to be very siloed. And we work with both of these types of companies. So for bigger industry, we tend to be smaller and more rapid, and we can do R&D, and we can help them do some things. And for smaller companies, we can be a bigger help. And all three of these types of companies sort of work together and with academia. It's a very, very general overview there. So I work at Leidos, and it's just to give you an idea. We're not going to dig into this, but it's a big-ish, small. It's a small, big company. We'll put it that way. And we spend a lot of time looking at civil, the health industry, and defense. So that's government, health, and the military. And one thing that I just wanted to highlight for people on this call is kind of some of the key things that you'll see that we look for in some of our quantum employees, right? So Leidos has a small select group of people who are cleared. They have PhDs or master's degrees. And this is kind of the moment where it's always a little difficult. I work in America. If you go into some of these industries, you'll find that they do have large defense focuses. And this is true in any country you go to, where depending on where you want to work, your ability to get that company's version of a clearance will potentially be important. So I'm just putting that out there because it's not always brought up. But for a company like Leidos, if you're going to be doing a lot of research, the end goal eventually is to work with the government in some way. So clearances are important. But we strongly value technical people, and we take good advantage of them in our company and work with them. So some of the places that we focus, if you ask someone, what is Leidos? This is kind of slide you'll get, which is digital modernization and cyber operations and mission software systems and integrated systems and mission operations. And you might be wondering, what on earth does quantum have to do with any of this, and why are we pulling it in? So I thought I would break down to what some of these things look like. I don't know how much of this is familiar to everyone. So research like this, very broadly speaking, quantum physics is the fundamental physics, and quantum technology is anything that levers it to do new capabilities, right? A quantum computer does things computers don't do. I'm sure a lot of people have seen this slide, but I always enjoy showing it to industry because they don't realize that you can basically do anything with quantum if you want to. Maybe you shouldn't, but you can. And so we look at all of these areas and try to see where they fit into some of those really big blocks that we mentioned earlier. And just to kind of break down a non-exhaustive list, but this is just some examples as to what some of these groups are looking for. So you heard in the previous talk, right? If the roads get too hot, we need to design new tires so they don't melt. So people who work in the civil infrastructure, so that's, energy, Department of Energy and infrastructure and things like that. Materials engineering is really, really important. Can we make more efficient wires? Can we make roads that don't melt our tires, or tires that don't melt on our roads? Can we optimize routing? I think everyone remembers during the pandemic, we had huge supply chain problems, and we don't want that to happen again. So routing is a very important thing to make sure people have what they need. Also for, even just sending missions to space or scientists to Antarctica, we want to be able to keep all of those running efficiently and smoothly. The surveying and mapping and detection that you can get with quantum sensors is incredibly valuable here. Optimizing batteries or securing communications, all of these things are very important. When you get into defense solutions, people look much more on the secure comms, the quantum encryption, but you get that overlap as well with really powerful quantum sensors. Chemical detection is really important for, say, protecting against gas attacks in subways. So looking at how you can get quantum sensors to detect chemical reactions. In health, quantum computing, again, is really important for drug discovery and modeling, the continuous monitoring you can get with quantum sensors. And then the revolution of making sensors smaller and more portable so that you can start taking things like MRIs or heart scanners to people who need them or can't get to hospitals. Data protection is a huge issue. And then, biomarker detection or nanoparticles for drug delivery. There's so many things that you can do. And so one of the reasons I'm so incredibly busy is there's so much we can do at Leidos, and there's a lot to look into. So kind of just to break down a few things, right? Like if you tell someone, oh, I'm in quantum communications, when you talk to a quantum physicist, that means one thing. But when you talk to a corporation, they're interested in a different set of things. So this is like the kind of slide you would use if you were selling, why do you care about quantum communications to a corporation? So speed, we know that quantum communications aren't as fast, but they are really good at detecting eavesdropper effects. And so if you're talking to anyone who's interested in data security or secured communications, this is really important, right? And so words like adversary profiling will come up, and shorter response times for security and improved trust in your communication. So these are the kinds of things when we talk about quantum comms, what people hear on the corporate side. What's really cool is I find that a lot of people don't know just how much work is being done, that we have these quantum and telecom networks being deployed in metro cities across the world, that there's the Quantum Internet Alliance in Europe, that BT and Cambridge have built theirs, that there's so much going on, and that a lot of it can be fit on our current infrastructure. So those are other keywords for corporate. Oh, I don't have to replace this. Oh, I can run this on my fiber. That you can do it between satellites, that you can send it over drones. These are all research projects that are going on. And then on the security side, you can't really fake or spoof entanglement, right? That you cannot fake an entangled particle, and it's very difficult to perfectly copy. It's pretty much, we have a theorem that it's impossible to perfectly copy data, which when you're talking to people who are interested in protecting social security numbers, to your health data, that's really important. But if you want to go on the flip side, on the red team, you can hide these signals as classical signals. You can enable true randomness if you want to secure your data. So that's kind of how the corporate world looks at things like quantum communications. And this is just like a cute overview drawing, but some of the things that also make it value is its ability to sense things. You have these quantum particles that you can seed into your communications lines, and they can either detect eavesdroppers or they can detect noise and environmental. There's, QKD papers where they've mapped out seismic activity in the area, which is sometimes bad and sometimes good because you don't want that to disrupt your communication, but it gives you a huge ground sensor as well. So some of the fun tie-ins that we get here with our classical companions at Leidos is, AIML signal analysis and signal processing and background rejection. So all the skills that you learn in physics or standard other data science, right, they all apply. So those are some of the things that we look at Leidos and broadly within the community. We talked about quantum computing in its application space, but I kind of wanted to discuss some of the other things that are really interesting, which is that the Defense Department and the government are very interested in using quantum computing, but it's not how they like to do that because most people don't like to send their secure data into a cloud and then hope it's okay. So when you talk about quantum computing to people who are more security focused, you end up with these really interesting sort of balancing discussions, looking into things like blind quantum computing. How do we protect analytics? Can we combine it with some classical techniques like fully homomorphic encryption, which means that you can do calculations on data that's encrypted while it's still encrypted? So there's a lot of extra layers to quantum computing beyond just the difficulty and the efficacy of using quantum computers to how do we use them securely? How do we make people feel comfortable? Is there a way to do automatic hybrid computation across different clouds, classical and quantum? Obviously, that's already being explored. So these are the kinds of concerns at a higher level when corporations and governments look into the use cases that are available. Some other fun things, I presume at some point this week, you guys have talked about nitrogen vacancy diamonds, which are very, very valuable as a sensor for being small and room temperature, but they are also very sensitive, right? The sensitivity is a double-edged sword. So some fun prototype research that we did with UMD, the University of Maryland, for example, was to see if we could combine a AIML cloud group at Leidos with a nitrogen vacancy center research group at the University of Maryland and see if we could find control pulses faster by doing parallelized AML techniques online. And very quickly we were able to reproduce most results. Like the AI algorithms were able to discover a lot of the pulse results that exist in published literature, and even a few more to help us develop these sort of iterative control capabilities. So when you look at a corporation, they see these great sensors, but they also say, how can I use it? What happens if it leaves the lab? So that's some of the research that we're looking for. I think, as I mentioned, Leidos talks to and works with other companies. So I wanted to highlight some other cool uses of sensors that exist elsewhere. For example, when we talk about nitrogen vacancy diamonds, this is something that Quantum Catalyzer is doing. The use cases are really broad. We think about it's a magnetometer, but they can do things from mapping out microscopic, sorry, my brain just had a brain fart, microscopic chemicals in the Earth's surface, but they can also use the same sensor to map out electric activity within microelectronics. And this group proved that they could see a Trojan actually turn on a chip. They could watch it happen with this sensor. So when you're talking about your research, these are some of the ways that industry is looking at it. And I just grabbed these because they were very different from some of the research we were doing. And when you start getting into sort of defense applications, I know this always sometimes is a bit tenuous a discussion here, but there's a inflection or cold quantum. I'm just highlighting this because it's a really great example of what industry sees when they look at quantum sensors, is they have this tiny little sensor up at the top, but at the bottom it replaces all of this hardware. So when people are looking at quantum capabilities, this is what the military or C-suite is thinking is, wow, I don't have to buy all these things. I can buy one of those and they're very small. So that's just to give you an idea of what people are looking at. And I just wanted to highlight some other people in the industry because the quantum industry is small, we help each other, and we frequently work together. Just a slide I didn't think you might have seen this week. There is a lot of interest on the defense side. You don't have to be interested in defense, but it's a different perspective, right? When you leave academia or you work on some of these startups, that you do also want to be aware where your technology might be going and what people might want to be using it for. So when you look at those clocks that are really helpful, and we discussed some of the use cases from before, you can use them to synchronize your GPS really well, but you can also use them to do stealth missions underwater. So it's something to keep in mind as you're looking around, is that there's a very, very broad use, and some of it is great. So we've done some research into detecting chemical weapons of mass destruction, so protecting people against those. So this isn't all, war and death, but I just thought it might be a picture that we don't usually show quantum physicists, and the government is this aware of all of the effects of quantum capabilities. So I just wanted to put that out there because I thought it might be different. And then just some of these overview slides that I don't know if you've seen, but the global idea of it's a very valuable field to be in. So as you are gaining your interest in working towards this, the world is pouring money into quantum globally. Just everyone is investing a lot of money. The United States is, China is, Europe is. So if ever there is a time, the investments keep going up. So it's a very good projection for wanting to get a job or wanting to get involved. On the United States side, they're pushing a bunch of acts together. We're not going to get into like government mumbo jumbo. Don't worry about it. But all this means is that the government has noticed that it's valuable. They're putting a lot of infrastructure in place to support companies, students, researchers, and they're really trying to build up a strong support infrastructure to develop quantum across the country. Excuse me. Um, and then they're very aware of this threat of quantum computers. So this is the thing that I hear about the most because I work at a company that focuses on cybersecurity quite heavily, which is we talk about all these really cool things that quantum computers do, but a lot of the government's focus right now is what happens if someone has one and they don't tell us. So quantum computers can break certain algorithms, and the problem with them is that they're very popular and heavily used algorithms. So there's concern because while some people say, quantum computers are 10 to 20 years away, the boring cybersecurity side is the last time we had to change one of these algorithms, it took us 10 to 20 years. So that's just a fun impact of some of the research that you're doing as well. And there's a lot of government mandates. We're not going to dig into this about how everyone needs to get ready for that and start preparing for quantum resilient cybersecurity. So the investment and attention is really there. Some cool things that you might be interested in on some of the government focus on funding, and this is not just military, right? This is government funding national labs and these microelectronic bills that support startups and academics. They're really interested in quantum sensing, quantum networking, and some of the cutting edge quantum physics that we can develop. And they're starting to look at it in 3 different ways, which I think is really exciting. So we have quantum science, which is that fundamental science research, quantum technology, but the government has now defined a bucket of quantum engineering, which is they're stating that we're getting ready to start selling these things as products, and saying that we have, research that's so strong that you can reliably say, I want a quantum blank, and we can go get it. So they see that in our future and they're investing in it. And the last thing that I wanted to point out is that we have a huge crisis, which makes all of you very, very valuable, which is that there is great interest, great funding, and not enough people doing quantum. So if you are in any way tangentially related to quantum, you are very valuable. Just about everyone is hiring. There are positions everywhere that we cannot fill. So know your value, reach out. There's a lot of opportunities out there from many of the places that you've heard of. And I think before I drown everyone in information, I will call it there. Thank you so much for the opportunity, Marlou.
Thank you so much, Elizabeth, for giving this really amazing and inspiring talk. Thank you. Also, really great overview. You are the last speaker of this month's intensive program. Tomorrow we'll have a career fair, and then we will have weekly sessions on quantum error correction and some others. But this was the best finishing talk. Thank you very much.
That's very kind of you. Thank you.
I would like to share a comment by Paulina. She says, thank you, Elizabeth, for such a thorough explanation of the structure in the companies and for allowing people to see various opportunities in industry. Extremely helpful.
Thank you.
Yeah. And Batul from Morocco, astounding talk, really insightful in terms of the industrial approach. The floor is open for questions. Could you share more about how the quantum chemical detection is done?
I can give you a general use case. So one of the, I don't have many regrets about going into industry, but one of the regrets I do have is that it gets very hard to talk to people about the cool things that you do. You can always publish your there's always a level of your research that you can publish and talk about, and then you can't. So one thing that I would talk about that's really cool is there's a type of very small quantum chemical sensor. So it's a thin film that you can fabricate, and they call these chemiresistors. So they are materials that change their resistance when exposed to certain chemicals. And if you put those in circuits, you can actually have the circuit behave and respond to chemicals that are in the environment. And these are what we call sort of passive sensors. They just sit there and they wait for a signal to come by. And then those circuits respond, obviously, to the chemicals, and you can get a detection from that. But what you can do with that is you can have these panels, and these chips are specific to different chemicals, right? So you can have little panels of all these different chips and deploy them in what we like to call autonomous sensor systems. So you can have a bunch of them spread out over a big area, and then they're all just sitting there and they respond by increasing their resistance. When a chemical comes by, that's a detection. But the cooler thing is if you have a bunch of these, you can actually do what we call plume tracing. So you can track the chemicals as they light up across a net of sensors, and you can kind of follow the threat and say, oh, it's dispersing this fast. And then, and this is where my material science comes back in, they have you can alter how you fabricate them. And based on your fabrication methods, you can change how fast they respond. You can change how sensitive they are. So you can tune them to the environments that you're used to looking at. So you get, I hope that's a good enough overview there, but we can't get too much more into it.
Yeah, thank you for sharing. Great. Also, in the beginning, you introduced your standard career trajectory. Very inspiring. Looking back, if you could start new again now, how would you do it?
Oh goodness, I would have done more math. I thought I was very proud of myself for not doing any math in college, and you can do anything with your career if you have the right tools. And I'll just share a funny story with everyone here. I took quantum physics and they introduced complex numbers, and I stopped the class by going, you can take the square root of a negative number? And that just like, it stopped the entire class for a minute. So I had to play a bit of catch up. But I think if you balance both like a good math background with a really good communications background or writing, there is nothing you cannot do, right? If you can think analytically, do the math behind it, and then communicate it, you are gold. So I think I would have not waited so long to pick math back up.
I see this is echoed by some people on the Discord. Then a question from Ron in Chicago. Relative to providing quantum services to clients, is the size of any given client drifting up or down? Ron asks.
Sorry, providing quantum service to a client?
Yeah.
So if you mean size by like the scale that we're looking at, I would say it's growing in two different ways, which is more people are interested and they're interested in bigger things. So we went from, say an organization like DARPA, they fund advanced research projects for the government, kind of like ARPA-E you were mentioning earlier. But they, we went from small niche places going, can you develop me this kind of sensor, to that turning into companies who go to places that build satellites and saying, wouldn't you want one of these on your satellite? So it's the scale of people interested are buying, and there's more people interested as well now.
Right.
I think if that answered the question.
Elizabeth, your story is inspiring. For someone like me, it's a validation. Then David asks, what are similar companies to Leidos, to get some more idea of the space?
Oh, I don't know if I can tell you that.
Oh yeah, maybe not.
No, I'm just teasing. No, we have I also don't want to seem too biased in my answer, but there are a lot of companies. So on the bigger side, there's companies like, you've heard of all of them, Boeing, BAE, Raytheon, Lockheed, they all have quantum divisions, like big ones. On the smaller side, there's places like SRT, SRI, MITRE, you heard from, the list goes on and on. At this point, you'd be hard pressed to find, we call them defense contractors, but most of those have quantum somewhere in them. It's a very big list, sorry.
Yeah, and David indeed asks about MITRE. Great to see that confirmed. Feroz asks a specific question. Let me see. He says, researchers use FPGA-based fully or partially holomorphic encryption for hardware acceleration. What is the role of quantum, more specific to holomorphic encryption?
That's a very specific question. Okay.
Thank
you for asking. So this is a research group that I am connected to, so I will give you the best answer I have on their side. So as you mentioned, the hardware acceleration is actually really critical. Fully homomorphic encryption or holomorphic encryption, those are very valuable, but they're very, very slow. So right now, the biggest place that industry is interested in is actually using it to protect against quantum. So not all FHE, but many FHEs have cryptographic primitives that are quantum resilient. So there's great interest in using them to defend against it. Um, I'm not going to wade into what we could do with quantum there, though I know there are places working on making quantum photonic chips. There are places working on integrating them with classical chips. So I think there could be some very interesting stuff that happens in the future, but that would be very speculative on my part.
Great. A brief follow-up from the chemical detection before by Dunya.
Mhm.
Are the chemical detectors already being used, or what is the TRL, the technology readiness level right now?
Oh, sure. I mean, that depends across industry, and I'll refer to like some public stuff. Like, for example, Samsung has detectors like this on chips in their products to detect corrosion. So those are in things you buy off the shelf. Some of them are, so having worked in fabrication, there's a little bit of a voodoo art and science as you figure it out, and it's very hard to get a good process that works. So every time you want to develop a new capability, a new sensor, a new reaction time, you have to start there and mess around with it. But the industry around fabricating a new type of chemiresistor or sensor like that to turning it into a product is very well known. So the hard part is coming up with the new materials and then moving them forward. But there's a bunch out there. They even have
Wonderful.
some for COVID. I found a paper with one that did like a little tiny graphene tattoo on your teeth to detect bacteria. Like it's mind blowing what's out there.
Yeah, we're in touch with that author for COVID. Everyone, if you want, we can still invite that speaker for a keynote on this Saturday session. Saha Rabba from CQ Tech Algeria asks, what are the right arguments to use and how difficult is it to convince governments to trust private companies on such sensitive quantum R&D and
Oh
engineering
dear.
projects?
I'm not going to say that I know all the right arguments. I think a really key thing that we need to be careful about as an industry is the hype is getting really big. So what I have found is very successful is to be extremely honest. Yes, I can help you here. No, I can't help you here. You want, yes, this is the kind of quantum sensor you want, but it's not going to work on an airplane, right? That's just not, it's going to break, or the entire airplane is too magnetic. But being very, very clear about what you can and cannot do is very critical. There's also, it's less the trust because they trust contractors to do a lot of sensitive defense work. It's more inertia, getting them to change well-known and very entrenched processes. So if you tell the government quantum communications is great, the first thing they say is, I don't want to replace anything. It's one of the reasons that QKD is having a hard time getting off the ground is because people don't want to buy another box that they have to put somewhere. Um, so it's usually just being honest and then finding ways where they don't have to change too much, but it's getting that momentum to change, right? I'm used to using this kind of sensor. I'm used to this. So knowing how it works in a platform or knowing the environment you want to put it in, that's very valuable. So like, hey, I know how satellites work. This is how we get one of these sensors onto a satellite. Things like that help. There's no one magic word though. And there's always one person who thinks you're full of hogwash. So you'll never convince them.
Yeah, great, very insightful. A question by Dawal from India. What skills and background do you look at for new job applicants, for candidates? How do you train them? Are you interested in generic engineers and let them do quantum? Do you want quantum experts?
That's actually a really good question, and it'll depend greatly on the company. So, but like for example, Leidos is very new to quantum, which I don't know if I mentioned, but we've started quantum 2 years ago. So that's how new some of these opportunities are. And so we're looking for multiple different things, right? We're looking for, someone with a quantum PhD where I can say, you know what, I just need you to go do this. Please make this work. But we're also looking for people who can understand the quantum PhD and also work with our maritime group and help them get sensors into ships. So we need those. I have a couple of just standard software engineers who now know more about quantum than they ever expected to. Because around all of this to make these things work, you need good software. You need a good hardware package, like the box that it sits in. So all of these skills are required. It'll depend on where each company is in their life cycle. So like startups, they want their bright tech people and they want their really good salespeople. And they want, Leidos is looking for a broad spectrum because we're starting from scratch. We need everybody. Some other companies will probably say, oh, we want to develop exactly this qubit. So we need just this guy who can do these photons over here, whatever they're working on. So I think I would say don't be afraid to think about how you might fit and try to sell that to somebody. I used to be embarrassed that I did creative writing and I wouldn't tell anyone until someone told me that words equal money when you work in business or even in academia, right? You're always writing grants. And so now that's something I highlight, right? I do quantum and I can write really well. So I think it's also for you to kind of see what do you want to do and how can you sell the skills that you have to a company, because we're usually looking for a lot more than we advertise for unless it's one of those very specific roles.
Perfect. And that also brings everyone into their sales pitch of themselves for tomorrow at the career fair. How can you sell that yourself, including creative writing, including other skills, to be appealing to the companies? Fantastic. Thank you so much, Elizabeth. I will check once more for the further questions. Yeah, everyone extremely enthusiastic, including the
Thank you
team.
very much.
Great to have you join us today, and we look forward to further being in touch and creating such exciting opportunities together. Thank
Yep.
you.
Thank you so much. I appreciate the opportunity.